Welcome back, guys. So I'm sure you would have gone through the earlier videos on number system, chapter. This is our last video, so we will be running through the exercises. Now if you have any doubt with regard to this chapter, you can always write an email to our email ID. Our email ID is askmentorguru@gmail.com. I will repeat, it is askmentorguru@gmail.com. ask mentor mentor guru guru @gmail.com. Okay. If you want detailed keys to each and every exercise, then we will provide it to you, but at a charge. Okay, that is chargeable. This I had mentioned in many of my previous videos. Personal appointments are chargeable. If you want me to run you through one chapter in detail as in a tuition, I will do that, but that again is chargeable. Okay. Otherwise, if you have difficulties in exercises, all you have to do is you write an email to me, to our email ID at askmentorguru@gmail.com, and we will definitely respond back to you. Okay. We will respond back to your email with the clarifications, right? So you need not have to really bother about having a personal appointment, etc. All you have to do is take some time off, write an email, right? You have to just mention the exercise, the sum, and communicate to me that you do not understand this particular sum. We will get back to you with a detailed step-by-step answer to that particular sum. Okay, so let us take exercise 1.1. So the first question is, you have been asked whether 0 is a rational number, whether you can write it in the form P by Q. That is a pretty straightforward question, right? So I do not want to get into the details of that particular question. Find 6 rational numbers between 3 and 4. Very straightforward. If you do not understand how to solve this, please refer to the example 2 available in page number 4. Okay, please refer to that example. There is a very similar question. Find 5 rational numbers between 1 and 2. Please refer to that. If you do not still understand, please send us an email. We will get back to you. The next question is also very similar in line. Find 5 rational numbers between 3 by 4 and 4 by 5. The fourth question is, you have to state whether the following statements are true or false. Pretty straightforward. Very simple exercise, See, finding out rational numbers between any two numbers, you have done it in your 8th standard itself. Exercise 1.2. The first question is, state whether the following statements are true or false. Justify your answers. Every irrational number is a real number. You know the answer. Please go through the video. You'll get the answer. Every point on the number line is of the form square root of m, where m is a natural number. Right? You know the answer. Every real number is an irrational number. Is it? Can we say every real number is an irrational number? Every irrational number is a real number. But is the converse true? I leave it to you. Are the square roots of all positive integers irrational? Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. I should not be giving the answer, right? You know the answer. Okay. Show how root of I can be represented on the number line. Right? how root 5 can be represented on the number line. So you have x, y axis. Okay. So how can you get root 5? See, if you draw a right angled triangle with 2 units on the x-axis and 1 unit on the y-axis, if you draw a right angled triangle, hypotenuse is root 5, right? So you just measure the length of the hypotenuse using a compass, okay, and then cut an arc on the x-axis. That will be the position of root 5. Okay, so you can try it out. Very similar example we had explained in our video. Please go through that and you will understand. Classroom activity. They are asking you to construct a series of, right? A series of, how do I say? A square root spiral. That is the terminology that is being used. Okay. So starting with a right angle triangle where you have base 1, altitude 1, you get root 2. Then you keep root 2 as the base. You have another 1 centimeter. Then you get root 3. You keep root 3 as a base. Draw another 1 centimeter. So likewise, you keep building this diagram. If you can really go up to, right, 25 iterations or 30 iterations, the spiral that you get is very beautiful, right? So you should, during your free time, take a very large sheet and draw the spiral. Okay, draw the spiral, color it, all right, and then you can take a picture and post it in your WhatsApp group, and you can ask your friends, what does this picture represent? Right? All top-notch artists, after drawing something, they would send it across to their friends and ask us, what does it represent? Does it what message does it communicate? Very similar to that, you can put the spiral, color it, send it across to your friends, right? This is sort of a mathematical artistry that we are talking about, right? So the spiral is very good. If you do it in a very neat fashion, the spiral is good. So you can try that. Okay, so this will be fun. Now let's go to exercise, the next exercise 1.3. Okay. The first question is, write the following in decimal form and say what kind of decimal expansion each has. Okay. So you have 36 by 100. It is very straightforward. It is 0.36, right? So what kind of a decimal expansion is this? It is a terminating decimal expansion, right? This particular fraction has got a terminating decimal. 1 by 11, you can divide and you can see whether it is terminating. If it is non-terminating, is it recurring? Or if it is non-terminating, non-recurring. This is what they are asking you to find out. Okay, so you divide each of these fractions and figure out if it is either terminating, if it is non-terminating, if it is recurring, or if it is non-terminating, non-recurring. So just to brush up your memory, any any decimal that is non-terminating and non-recurring, it is an irrational number. Just remember that. The second question is, you have 1 by 7 equal to 0.142857 and there is a bar, which means that block is recurring. Okay. So can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? So what you have to do is, let us take 3 by 7. Take the first quotient, right? When you divide 3 by 7, your first quotient will be 4. Okay. 4 7s are 28. So it will be 0.4. So the first digit of the decimal in your quotient starts with 4. Okay. And it has got a pattern. See, in 1 by 7, the first digit is 1. Okay. And second digit is 4. Right. See, this pattern is maintained. Right. Which means in 3 by 7, since the first digit is 4, the second digit will be 2, the third digit will be 8, the fourth digit will be 5, the fifth digit will be 7, and the sixth digit will be 1. Okay, so all you have to do is just find the first digit of the quotient, then the rest of the thing based on the pattern in 1 by 7, you just fill it up, right? That will be the quotient, or that will be the block that will be repeating for 2 by 7, 3 by 7, etc. Take the case of 4 by 7. Okay, it is what, 5 sevens are 35, right? Okay, so the first digit is 5. So after 5, what do you get? In 1 by 7, you have 7. So after 5, you put 7. And then 1, then 4, then 2, then 8. Okay, so this block keeps repeating. So there is a pattern. If you recollect in one of my videos, I had asked you to, put a sort of a table and keep filling up the remainder and the quotient, right? And I had asked you to analyze if there are any patterns. Okay, the reason that I asked you to do during your learning lessons is because I knew that this problem is coming. So for you to understand about the what do you say, the pattern is the reason why I had asked you to do the other exercise. Okay, all right. The third question is, express the following in the form P by Q, where P and Q are integers and Q not equal to 0. See, 0.6 is given. So you take x is equal to 0.6, multiplied by 10, it becomes 6.6. 6 plus 0.6, right? So again, substitute, for 0.6 recurring as x. So you have 10x is equal to 6 plus x, right? So 9x is equal to x is equal to 6 by 9. Simplify, you get the answer. All the others are very similar in line. Fourth question is also same. Express 0.99 in the form P by Q. Okay. What can be the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 17? What is the maximum number of digits that keeps repeating in the block 1 by 17? Just keep on dividing. If my memory is right, it was around 14 digits or something. Okay. After that, it will keep repeating. Alright, so that you can find out. See, all other things are pretty much straightforward. So you attempt those problems, and then in case if you have any questions, please revert back to me. I will clarify those questions. Alright, so the next two exercises I will cover in my next video. Alright, because I am making sure that the size of the video do not exceed or should not exceed a certain number of minutes. I do not want any video to exceed 13 minutes or 14 minutes. Okay, so that is why I am restricting in this video. I will continue the exercises in my next video. Please wait for my next video. Please remember to subscribe. Please remember to press the bell button. If you have any comments, please drop in your comments. Please share it with all your friends, right? Because each one of you should benefit out of these videos. All right, thank you. Please wait for my next video.